Hello and welcome. I'm Aishwarya with you. Today we will be looking in depth into the NASA's Voyager2 mission. In the blackness of space, billions of miles from home, we are learning that a second object from Earth has crossed the influence of the Sun. NASA has disclosed that its Voyager2 mission became the second spacecraft ever to enter interstellar space last year in November 2018. And now, a day after the anniversary of that event, now scientists have revealed what Voyager2 saw when it crossed that threshold. And it is giving humans new insights into some of the big mysteries of our solar system. So here is a glimpse of Voyager2's 12 billion mile long journey and what its latest revelations mean to our understanding of the space and beyond. Billion miles from Earth, there is an elusive boundary that marks the edge of our Sun's realm and the start of the interstellar space. When NASA-2's Voyager2, the longest-running space mission, crossed that frontier, more than 40 years after its launch, it sent a faint signal from the other side that scientists have now decoded. Voyager2 mission is only the second spacecraft ever to enter interstellar space after its twin Voyager1. So here is a detailed report about NASA's Voyager mission.
The Voyager mission is an American scientific program to study the outer solar system. It employs two robotic probes, Voyager1 and Voyager2. Both probes were launched in 1977 to take advantage of a favorable alignment of Jupiter, Saturn, Uranus and Neptune. This alignment occurs every 175 years. It allows spacecraft on a particular flight path to swing from one planet to next without need for large propulsion systems. While the four-planet mission was known to be possible, it was too expensive to build a spacecraft that could go the distance, carry the instruments needed, and last long enough to complete such a long mission. Which is why the Voyagers were funded to conduct intensive flyby studies of Jupiter and Saturn alone. But both Voyagers did more than that. Continuing their more than 40-year journey since their launch in 1977, they are today much farther away from Earth and the Sun than even Pluto. The Voyager mission went far beyond Jupiter and Saturn, and Voyager2 went on to explore Uranus and Neptune. It is still the only spacecraft to have visited those outer planets.
That is on November 5, 2018. The Voyager2 crossed this point. Of course, that day we didn't know that it has crossed the point. Okay, the data came because data will come very, very slow. So data came, and we have now analyzed and we have found that that is where the crossing is happening. We know it by measuring, for example, the magnetic flux. So if you are measuring magnetic flux in Earth, as you go away from the Sun, as you go away further and further, the magnetic flux will slowly come down. Okay, this side. Okay, at some point it will come to very low, and the magnetic from the interstellar will be high. So which means that you have crossed to interstellar space. I mean, this influence is very little, and that influence has started. So a spacecraft will measure it, and it has to send the data to Earth. Then you have to analyze the data, and then you will have to come to the conclusion. That is why it took 1 year. Actually, the Voyager2 crossed this boundary on November 5, 2018.
In August 2012, Voyager1 made the historic entry into interstellar space, the region between stars, filled with material ejected by the death of a nearby star millions of years ago. On November 5, 2018, a study published in the journal Nature Astronomy confirmed Voyager2's passage into the interstellar space medium. According to the scientists, this makes Voyager2 the second human-made object to journey out of the Sun's influence following Voyager1's solar exit in 2012. According to researchers at the University of Iowa in the US, Voyager2 instruments are in better shape than the Voyager1, So scientists could see the transition from the space dominated by the Sun to the interstellar medium. Data from Voyager 2 also gives clues to the thickness of the heliosheath, the outer region of the heliosphere and the point where the solar wind piles up against approaching wind in interstellar space. Both spacecraft are still sending scientific information about their surroundings through the Deep Space Network. Bureau Report, Rajya Sabha TV.
So on 5th of November 2018, NASA's Voyager2 spacecraft became the second human-made object to cross into the interstellar space. But before its historic crossing into the interstellar space, it had already served humanity well. Well, it swung past Jupiter, Saturn, Neptune and Uranus and has been in space since 1977. So take a look at Voyager2's epic journey so far.
3, 2, 1. We have ignition and we have liftoff.
NASA launched Voyager2 space probe on 20th of August 1977. As part of the Voyager program, it was launched 16 days before its twin, Voyager 1. Voyager 2's trajectory took longer to reach Jupiter and Saturn, but enabled further encounters with Uranus and Neptune, becoming the only spacecraft to have visited either of these two ice giant planets. So here is a look at the journey of Voyager 2. Jupiter leg of the journey. Voyager 2 arrived at Jupiter in July 1979. 4 months after Voyager 1. The camera on board Voyager 2, much like Voyager 1, captured many incredible photographs of our solar system's largest planet. It also captured Jupiter's several moons, changes in its moon surface and its volcanic eruptions. Voyager 2 explored the giant planet, its magnetosphere and moons in greater detail than Voyager 1. It showed in detail the streaks Voyager 1 had shown on Jupiter's moon Europa into a collection of cracks in a thick and remarkably smooth icy crust. It also discovered a 14th moon and revealed a third component to the planet's rings. Saturn leg of the journey. After its encounter with Jupiter on 25th of August 1981, Voyager 2 arrived at the ringed world of Saturn. Using its photopolarimeter, an instrument that had failed on Voyager 1, Voyager 2 was able to observe the planet's rings at much higher resolution and to discover many more ringlets. It also provided more detailed images of the ring spokes and kings and of the F ring and its shepherding moons. Uranus leg of journey. Following its flybys of Jupiter and Saturn, the spacecraft continued on to the next distant world, one that had never been visited before. In January 1986, Voyager 2 became the first spacecraft ever to reach Uranus. This true color image was taken 5.7 million miles away from the planet, and though the planet appeared to have few features, it does reveal its blush blue color due to methane cloud in its atmosphere. Voyager 2 also found evidence of an ocean of boiling water about 800 kilometers below its cloud tops. It discovered Uranus' 10 new moons, 2 new rings, and a strangely tilted magnetic field. Neptune leg of journey. More than 3.5 months after the Uranus encounter, Voyager 2 had only one last world to capture. On 25th of August 1989, the spacecraft arrived at Neptune, again the only human-made object to have flown by Neptune. This image shows the planet's bright blue color and the planet's cloud tops. It discovered Neptune's 5 moons, largest of which is Triton, and which was found to be the coldest known planetary body in the solar system, with nitrogen ice volcano on its surface. The pictures showed a Triton's surface that is a frigid minus 235 degrees Celsius. After achieving its primary mission, Voyager 2 is now in its extended mission to study the outer reaches of the solar system. NASA announced in December 2018 that Voyager 2 had entered interstellar space, the second spacecraft to do so after its sister ship Voyager 1. It has been operating for 42 years, 2 months and 10 days as of 6th of November 2019. It is expected to continue operating at least one instrument up till 2025. Then it will slowly shut down and will continue to drift through the darkness of space. Bureau Report, Rajya Sabha TV. And in depth, we'll take a very short break and more details on Voyager 2's journeys and accomplishments on the other side. Stay tuned. Welcome back after the break. You're watching In Depth, and before the break we told you all the details about the Voyager 2, and now let us know about Voyager 1, which is a space probe launched by NASA on 5th of September 1977 and part of the Voyager program to study the outer space system. Voyager 1 was launched 16 days after its twin Voyager 2. Voyager 1 carries a copy of the Golden Record, a message from humanity to the cosmos that includes greetings in 55 languages, pictures of the people and places on Earth, and even music. Let's find out more details about Voyager 1 in this report.
Voyager 1 departed Earth on September 5, 1977. Part of the Voyager program to study the outer solar system, it was launched 16 days after its sister spacecraft, Voyager 2. Having operated for 42 years, 1 month and 30 days, as of 5th November 2019, the spacecraft still communicates with the Deep Space Network to receive routine commands and to transmit data to Earth. The probe's primary objective was to survey the planets Jupiter, Saturn, and Saturn's largest moon, Titan. Voyager 1 studied the weather, magnetic fields, and the rings of the two planets and was the first probe to provide detailed images of their moons. After completing its primary mission with the flyby of Saturn on November 12, 1980, Voyager 1 became the third of the 5 artificial objects to achieve the escape velocity required to leave the solar system.
In 2012, Voyager 1 crossed what is known as the boundary between the solar system and the interstellar space. What does it mean? It means, like, say, for example, you are in Delhi. All around us is India, right? At some point of place, the India ends and the neighboring country begins, right? That border. Of course, on a geographical border, it's like a thin line. I mean, we put a fence or maybe a marker or something like that. But in actual space, there will be no marker. But the difference would be that the effect of sun will be substantial up to that point. And after that point, the effect of the other stars will be more than the sun. That is how you define that place. This is called as heliopause. Okay, that heliopause, it crossed in 2012, Voyager 1. But unfortunately, what happened in Voyager 1 is that the instrument which was supposed to measure the plasma, magnetic flux and cosmic ray intensity, solar wind intensity and cosmic intensity got damaged because of the various fluctuations. The instrument was not very robust. So it could not actually find where the thing ended and where the beginning, next, the interstellar space began.
NASA's Voyager 1 began its Jovian imaging mission that pertained to the planet Jupiter in April 1978, when it was about 165 million miles from the planet. Images sent back by January 1979 indicated that Jupiter's atmosphere was more turbulent than during the Pioneer flybys in 1973 and 1974. Beginning January 30, 1979, Voyager 1 took a picture every 96 seconds for a span of 100 hours to generate a color time-lapse movie to depict 10 rotations of Jupiter. In March 1979, it discovered a thin ring encircling Jupiter. The spacecraft also discovered 2 new moons of Jupiter, Thebe and Metis. Its flyby of Saturn in November 1979 was spectacular. Voyager 1 found 5 new moons, a ring system consisting of thousands of bands, wedge-shaped transient clouds of tiny particles in the B ring that scientists call spokes, a new ring, the G ring, and the shepherding satellites on either side of the F ring, satellite that keeps the rings well defined. On February 14, 1990, Voyager 1's cameras were pointed backwards and captured about 60 images of the Sun and planets. These images were the last of 67,000 images taken by the two Voyager spacecraft. Their cameras were turned off to save power and memory for the interstellar mission. All the planetary encounters were finally over in 1989. On February 17, 1998, Voyager 1 became the most distant human-made object in existence when at a distance of 69.4 astronomical units or AU from the Sun, overtaking the Pioneer 10. On December 16, 2004, it was reported that Voyager 1 had sent back indications that it had reached termination shock, which is the boundary marking one of the outer limits of the Sun's influence, and had now entered the heliosheath, the region beyond that. The spacecraft finally exited the heliosphere and began measuring the interstellar environment on August 25, 2012, the first spacecraft to do so. Voyager 1 also carries a copy of the Golden Record, a message from humanity to the cosmos that includes greetings in 55 languages, pictures of people and places on Earth, and music.
So sometimes many of these kind of scientific experiments you start, but the fruit will come very much later. It takes a lot of time. Of course, the Voyager also did a lot of work within the solar system. I mean, it visited Saturn, Jupiter. We were able to get much more information about, for example, planet Uranus. Some people were actually saying that about Neptune, what we knew before the Voyager 1 and Voyager 2, you can write on the backside of a stamp, postal stamp. That's all we knew. But after the Voyager 1 and Voyager 2, you can write a book. That's much we have known. So Neptune, we know that it existed, that's all. I mean, how much time it takes to go around the Sun, we knew very little. But with the Voyager 1 and Voyager 2 data, we came to know a lot about Neptune, which is the 8th planet in our solar system. So it has also done a lot of work, interesting work within the solar system.
Voyager 1 is now over 11 billion miles from the Sun and far from its warmth. To ensure the vintage robots continue to return the best scientific data possible, mission engineers in 2019 began implementing a new plan to manage them. The goal of the new mission is to extend NASA's exploration of the solar system beyond the neighborhood of the outer planets to the outer limits of Sun's sphere of influence and possibly beyond. Bureau Report, Rajya Sabha TV.
Well, throughout the program, we've been talking about the interstellar space. So what is interstellar space? The vast stretches of space that fall between the illuminated regions where stars sit is known as the interstellar space. In simple words, it can be defined as the space between stars, but can also refer to the space between galaxies. Now, many satellites have been launched with the intention of sending back information from the interstellar space. These, of course, include the Voyager 1 and Voyager 2 spacecraft, which have cleared the known boundaries of the solar system and passed into the heliopause. So here is a detailed report explaining what interstellar space actually is.
When we talk of outer space, we imagine individual stars separated by great distances with a vacuum between them. While it is true that the space is mostly empty, there are regions within that are filled with lots of material. The interstellar medium consists of all such materials, which are mainly gas and dust. In total, about 15% of the visible matter in the Milky Way is composed of interstellar gas and dust. Scientists define interstellar space as the place where the flow of gas and dust from the Sun as well as its magnetic field stop affecting its surroundings. This place is called the heliopause. This marks the end of a region created by the Sun that's called the heliosphere. The Sun creates this heliosphere by sending a constant stream of particles and a magnetic field into space at over 670,000 miles per hour. This stream is called the solar wind. Like the earth wind, this wind pushes against the stuff around it. Inside the heliosphere, the solar particles are hot but less concentrated. Outside the bubble, they are very much colder but more concentrated. When a man-made mission arrives in interstellar space, there would be an increase of cold particles around the subject. It would also encounter a magnetic field that does not originate from our sun.
In the solar system and interaction between interstellar medium, there are layers. That's what this Voyager 2, because its instruments were functioning, was able to find. Why these layers occur? Because at the edges, there are many things which are interacting. One, the sun is sending lots of charged particle, which is called as solar wind. Similarly, other stars will be sending solar wind. They both are meeting there and interacting. Then sun has a magnetic effect, so it will have effect. Similarly, other stars will have magnetic force, field. They will be interacting. Okay. These and plasma, for example, sun will be ejecting a lot of plasma, other stars will be ejecting plasma, these will be interacting. All this interaction has created at the edges some layers. So that is what this new research is saying. So we are getting to understand how the heliopause, that is the edge of solar system, and the interstellar are meeting.
Another crucial term that is of interest to the astronomers and scientists is the interstellar medium, or ISM. This is matter that fills interstellar space and blends smoothly into surrounding intergalactic space. The energy that occupies this region, or electromagnetic radiation, is the interstellar radiation field. ISM is made up primarily of plasma or ionized hydrogen gas because its temperature is high by terrestrial standards.
Two human-made objects, Voyager 1 and Voyager 2, have crossed solar system and has gone to interstellar space. So one way we can say that humanity has not just landed on moon or gone to planets within solar system, we have also crossed solar system. This is the importance of this event.
The term interstellar medium first appeared in the 17th century in the works of Sir Francis Bacon and Robert Boyle. Before electromagnetic theory arrived on the scene, early physicists believed space must be filled with an invisible ether in order for light to pass through it. It was not until the 20th century that deep photographic imaging and spectroscopy showed that matter and gas existed in these regions. The discovery of cosmic waves in 1912 further led to the theory that interstellar space was pervaded by them. With the coming of ultraviolet, X-ray, microwave and gamma-ray detectors, scientists are now able to see these kinds of energy at work in interstellar space and confirm their existence. Bureau Report, Rajya Sabha TV.
And that's it from us today in depth. We'll be back same time tomorrow with a focus on another key subject. You can also watch our program online on YouTube, the link for which is flashing on your TV screens. And suggestions and feedback about the program are welcome. Thank you so much for your time. Bye-bye.